so that I have enough lighting, shadows into the living room. How are you going to do it? Okay, you have to have so-called perform analysis. All right, I mean, we are living in 21st century already. We cannot go back to so-called, doing a line sketches, all right, to come up with the solar, azimuth, solar, angles just to tell you how much shadow. No, we are living in simulation world. Okay, so in other words, your design, okay, whatever, all right, you should base on design based, maybe evidence based kind of activity. I recently was called in to talk to Singapore Institute of Architects, the executive director. Right, he was asking me, can I help them to develop a software that is meant for architect? So I said, why they cannot use our software like that? They said, no, architects are very lazy. Okay, architects want to see, all right, they don't want to go into the so-called math behind it. So are you of that kind of people? Okay, I hope you're not. Okay, all right. So we have to design another so-called software for them. All right, but let me just show you something. All right, with simulation technology, you can do something like that. All right, you simulate the sun path. From the sun path, you get a shadow. Okay, all right. So any single hours of the so-called of the day, of the month, of the year, you can have a good so-called good understanding of the shadow. Understand? This is what architect is also looking for. All right. So if you don't have the so-called the detail of the model, either be BIM or Google SketchUp, sorry, you are not addressing the needs. I mean the so-called the design consideration. You understand? Okay. So in other words, not only you will need to create a 3D nice model that is really so-called realistic model, all right, faithfully, all right, but you also have to have so-called a simulation so-called skill set that go with your design. All right. Now, how about this baby? All right, we come back to this one. All right, just now was just a house, but are you able to so-called analyze the shadow, the solar potential of this building? All right. Architect also want to look at the aesthetic when you go for presentation, all right, to win project, to submit your bids, all right, your tender. Architect want to have that kind of presentation, right? Though go hand in hand with it. So without a 3D model rendering, all right, you guys will not be able to have an upper hand compared to your competitor. Okay. All right, now, Sophie, right, come up with this design. So what is the consequences of having a fountain inside this building? Okay, all right. So do you have the right skill, right, the technology to address all these concerns, right, if you want to be world class? Okay, so that one is a pictures that I took. That one is a simulation. Okay, but it's not perfect. But at least you have some things in the fingertips to address a certain concern. All right. If you go to the so-called the local, the site, you realize that water is splashing. Yes, water is splashing. But question is, splash by how much? Okay. So design. All right. Performance. Shadow analysis. All right. Shadow analysis. Look at the roof. All right. There are so many so-called structures. So in other words, if this is a garden, all right, on the right is actually so-called the pictures I took, and that pictures on the left is when we help them to look at the shadow, okay, because they need to decide which plants, what kind of plants to plant, all right, at what location, because these plants are very expensive. Some of them actually imported from overseas. Okay, so in other words, not only you need to have a model, the concept, all right, and also the simulation tools, the things, all right, to help you to justify your design. Okay, so on and so forth. Now, so I'm showing you a video that we did many years ago. Okay, all right, just to show you that no matter how complex, okay, all right, if you have a good tools, you can do, all right, your job very well. This was a video. This was an animation, simulated animation. All right, for a shadow that we did, all right, for RSP many years ago. All right, so it's a very big project. But without BIM modeling, without so-called, the 3D model provided by architect, again, all right, we cannot start anything. So it's an integrated design process that you need to team up with your, the different so-called people. Understand? All right, let's move on because I do have a lot of things to talk. All right, now, so shadow analysis is just one of the so-called, activity. This is the latest one. All right, we have actually the changes the background so that it become more realistic. Okay, all right. The previous one I show you is older versions. All right, in 2015. All right. Now another aspect is now we talk about sustainability. Okay, we want to create net zero building. Okay. Yes, you look at the passive design, but now you want to so-called you want to make the so-called energy efficient or energy net zero building. In other words, you may want to consider the installation of solar film. You want to install the solar panels on your roof. All right. So all these things, how are you going to do it? All right. So now I like to highlight these pictures because a lot of people think that hey, you have a flat roof on the HDB flat. On a high-rise building, you have the full area for you to implement PV panels, right? Yes or no? Wrong. When you go up to the so-called the rooftop, what do you see? You have lift shaft, you have water tank, right now. So all this so-called object, building elements, are they higher than the roof? Yes. So in other words, you don't so-called install solar panel next to those building element. Understand? All right. So building like that is nothing. All right. And BIPV. How many of you actually know what is BIPV? BIPV. All right. BIPV is a new kind of PV cell, PV panels. Actually, they install on the vertical, so-called facades. So again, all right, if you look at the buildings, in fact, the facades, the vertical area, all right, on the building facade is much bigger than the rooftop. So therefore, all right, these will be the trends in the future. People are going to install BIPV on the vertical facade, on the buildings, facade, rather than in addition to the rooftop, all right, location. All right, same thing for this project. They also make use of solar panels, all right, to make the jewel, all right, energy net zero, okay, all right. So the details I do not have it, but at that time we actually do so-called some analysis. We do the solar potential analysis and to tell them how you could place your solar panels at what location and what amount you can get, all right. So and beside so-called the jewel. The train station in China, same thing. We analyze, okay, so and so forth. All right. So going back to the building just now, okay. If you really want to interested in installing solar panels, and you can actually use the software tools to estimate what is the amount of energy that you can harvest for 1 month, for 1 year, or even for 1 day. All right. Okay. All right. So besides solar shadow. All right. Another aspect in your designs, so-called workflow, you may have to consider daylighting. That means you design so-called auditorium like this, or maybe a meeting room. You want to quantify what's the amount of so-called daylight you can actually harvest, you can get. If it's too dark, then you have to install lighting. All right. So this lighting, all right, is additional energy. So you want to maximize the daylight, the sun exposure, but you also need to look at the compromise between the two, because if you have daylight and also you may have so-called additional solar energy penetrating into the room. Okay, so you have to go through all this process. All right, don't just come up, oh, I have this design, that's it. All right, you need to justify with all these sort of requirements. All right, you need to use simulation to calculate the daylight factors, the luminous, illuminous, and so on and so forth. All right, so-called daylight factors. Okay, so these are the typical application. All right, so at this moment, am I overwhelming you guys? Okay? Right? So feel free to talk, feel free to so-called jump in to ask questions. All right, okay? Because I think it's good that, you know, to have this kind of interactive mode of a talk rather than I give everything and then at the end of it you may have forgotten the question. All right, go ahead. Sorry? BIM. Building integrated. BI stands for building integrated, all right, photovoltaic. Huh? I said BIPV. BIPV.
No, I think he's referring to your slide. There's a DIVA too.
Oh, the DIVA is a software. DIVA. All right, DIVA is a software. It's a well-known software. Okay, for daylighting. Yeah, daylighting. Okay. Now, energy. All right. So during your design, you also need to quantify what is the energy consumption. Okay, and also estimate what is the so-called. I mean, for Singapore, tropical country like Singapore, you need to quantify. Okay, the energy need to cool that space so that you know you estimate the energy bill. Okay, so that's energy simulation. All right. So tools, all right, like BIM tool, like IES, okay, like Energy Plus, so on and so forth, can be used. So in other words, all right, you guys should think ahead, okay, all right, and start to think about what do you want to do, and then start to learn about the software to get yourself ready for all this sort of application. All right, so there are tools like that. If you're really interested in the HVAC, like chiller, okay, the fan coil, all right, you need to go beyond that. All right, you need to select a software like, you know, Digital Alchema, the Synergy, all right, to look into the chiller, okay, the fan coil unit, all right, FCU unit, things like that. Now, airflow, you have seen Owen's presentations. For their Sabana Jurong, they actually maximize, I mean, the use of CFD to help them to design the air path, okay, to create the kind of thermal comfort, all right, to deliver that kind of ventilation effect that they want. So simulation software, simulation CFD software like Fluent CFX, all right, OpenForm, all right, are very, very important. So you know, please look into that. All right. Now, let me ask you a question. What is this? What is this? Huh? Architect student? Sorry? Huh? The air vent? The air vent? Who's the instructor? If architect students do not know what it is, I think that is no good. Anybody know what is this? Wind tunnel. Okay? All right. So in the good old days when you do not have CFD, you have to come up with your model and to put it inside the test sections, and then you have to blow a lot of wind down, all right, into the sections, test sections. Then you start to measure all those so-called pressure, you know, the speed, things like that. Okay. But nowadays with the advance of computer, all right, you will see less and less this kind of hardware around anymore. Okay? All right. So the question here is that why I want to put it in here. All right? Because recently we have come across a project. All right? The wind tunnel designer approached us to request us to help them to come up with a better wind tunnel design. Does it make any sense to you now? So for example, like your master of master. Got what I'm saying? That means the CFD tools is very powerful tools. We know that wind tunnel, you know, is used to design, is to help the building designer to come up with a better building design. But now, if you master the software tools like CFD, you can help the wind tunnel designer to design wind tunnel. Got it? All right. If you don't understand, that's all right. Okay. All right, so the use of CFD can be internal, can be external. So this is a list of software that you might want to go and do some research, you know, to prepare for your design competitions. All right, so from the left is ANSYS, very famous. All right, so Numerica, Star CCM, okay, open form, creator. All right, so please ask your instructor for more information. Okay, so out of all this software, one thing that stands out, okay, in fact, I would strongly advise you guys to do some research. Okay, so what is, now look into what is CAD-centric versus BIM-centric. You guys are in building industry. Do you know what is CAD? No. But do you guys know what is BIM? Yes. So in other words, your simulation tools that you want to use should be BIM-centric rather than CAD-centric. Okay? So most of the software, CFD software out there, they are not CAD, they are not BIM-centric, but they are CAD-centric. Okay? So with CAD-centric technology, you can bring in your BIM model right away. Okay? In other words, your design competition ends in July. If you don't use CAD-centric, your simulation will not happen in July. In other words, you don't have to submit your design competition, okay? Because it's way past the deadline. All right, so you need to learn, okay? So there's one thing that I want to highlight is with BIM-centric, you can save you a lot of so-called time and efforts in getting a model created for simulation. You know, just now those pictures that's shown by Owens, they are the end result. They are the end of it already. But before you see those colorful pictures, there are a lot of effort you need to put in to generate those results. So please don't wait until last minute, because the whole design competition is not supposed to do one simulation. I repeat, it's not just to repeat one simulation for your final design. You need to impress the so-called judges on your so-called your development. All right, you may have to do a few simulations, all right, and so-called record it just to show that, hey, this is a progressive activity. All right, you analyze the first simulation, find that it's no good, you improve on it, and come up with a second option. Okay, so it takes a lot of time. All right, so you can do simulation for simple buildings,